Caching in computer architecture is a fundamental technique used to improve system performance by reducing the average time it takes to access data. It works on the principle of locality of reference, meaning that the program tends to access the same data or data in nearby locations repeatedly over a short period of time. Now, this is how it generally works. So, high speed and small memory. A cache is a smaller, faster memory component, typically the SRAM or the static RAM, positioned between the CPU and the main memory, like the DRAM or the dynamic RAM, however you say it. Now, there can be multiple levels of cache. We have the L1, the L2, and the L3, with the L1 being the smallest and fastest, closest to the CPU. Now, the CPU requests for data. Now, when the CPU needs a piece of data or an instruction, it first checks the cache. Now, the cache hits. If the requested data is found in the cache, it's called a cache hit. The CPU retrieves the data directly from the cache, which is a very fast operation due to the cache high speed. This saves a lot of time compared to accessing main memory. Now, the cache miss. Now, what about this one? So, if the requested data is not found in the cache, it's called a cache miss. In this case, the CPU has to fetch the data from the next lower level of memory, like the L2 cache or the L3 cache, then the main memory, and finally storage if it's not in memory. Once the data is retrieved from the slower memory, a copy of it is then placed into the cache. This is done because of the locality principle. If this data was just accessed, it's likely to be needed again soon. Now, the cache lines or the blocks. Data is not moved into the cache 1 byte at a time, but in fixed size chunks called cache lines or cache blocks. This is efficient because if you need one piece of data, you are likely to need nearby data too, which is the special locality. Now, replacement policies. Caches have a limited size. When a cache miss occurs and a new cache line needs to be brought in, but the cache is already full, an existing cache line must be evicted to make space. Replacement policies are algorithms used to decide which existing cache line is removed. Common policies include the LRU, which is the least recently used. We have the FIFO, which is the first in, first out. We have the LFU, which is the least frequently used. Now, we also have the write policies. When the cache writes data, there are different strategies for updating main memory. Now, we have the write through, which is the data is written simultaneously to both the cache and the main memory. This ensures consistency but can be slower. And we have the write back, and that one is if data is initially written only to the cache, main memory is updated later, often when the cache line is evicted from the cache. This is faster for write but introduces a potential for inconsistency if the system crashes before the main memory is updated. Now, in essence, caching acts as a buffer or a temporary staging area for frequently used data, making it readily available to the CPU and significantly boosting the overall speed and efficiency of a computer. I hope you learned something new. Thanks for watching.